Hello and welcome to another tutorial. In this tutorial I'm going to show you how to identify the pins of a transistor. I'm going to show you how to identify the base, the emitter and collector of a bipolar junction transistor. So we are going to start with a brief theory on transistors. Transistors are broadly categorized into two. We have bipolar junction transistor and field effect transistor. Under bipolar junction transistor, they are also subdivided into two. We have NPN and PNP. N and P show the type of semiconductor connected to that particular terminal. So these are the three terminals. One of the terminal is N, one is P, and the other terminal is N. Bipolar junction transistors is simply having two diodes either facing each other or facing away from each other. Excuse. This is a simple diagram of a diode. A diode simply is a two-terminal semiconductor device that allows current to pass through it only in one direction. And when it allows current to pass through, the diode is said to be forward biased. So this is my anode, which is made of P-type semiconductor, and this is my cathode, which is made of N-type semiconductor. So basically what I'm saying is this: a PNP transistor, these are the three terminals, PNP. So one of these these terminals represent the base, emitter and the collector, but at the moment we don't know the terminals. So we are going to do practically to identify a PNP and also do it practically to identify an NPN transistor. So straight to how we're going to measure. This is my first transistor, which is BC547. I'm going to plug it in my breadboard. This is my breadboard. I have my digital multimeter here. So I power my digital multimeter and turn my select knob to where we have diode stroke continuity test. Then you're going to prepare a table like this. This is BC547 pin identification with the flat side facing you. So this is my BC547 with the flat side facing me. This is going to be my pin number 1, the second one my pin number 2, and far to my right my pin number 3. So this is the transistor. It's in my breadboard there. This is the table we are using, guys. So this table, it's prepared like this. Where I have red, it's the red probe of my multimeter, this one. And where I have black, it's the black probe of my multimeter. So how do we measure it? The first one, it's when I have my red on 1 and my black probe on 2. So with my multimeter like that, red is on the first pin like that and black on the second pin. You can be able to see the reading that I'm getting is what? OL. So you record that here. You record it like that. Secondly, we have what? We have 1 and 3. So red on 1 and black on 3. Still no current is passing through. So you come to your table OL. Now my red terminal is on terminal number 2 and my black probe is on number 1, and you can be able to see we are getting a value which is 717. So you record that 717. Now it's red on 2 still, but black on 3. So red on 2, black on 3. And what value do you see there? 724. 724. Now you exchange the probes. You take the red probe to number 3 and the black one to number 1 OL. Red still on number 3, black on number 2. The reading is OL. So now this data is going to help us to identify our terminals, because we have said it's either having diodes facing each other or diodes facing away from each other, and diodes only allow current to pass through in one direction. So in values where we got a reading, it means that the diode between that junction is forward biased. The diode between that junction is forward biased. So with that in mind, we can say that pin number 2, this reading is going to enable us to understand the pins, to identify the pins. So this is what we do. Identify in the readings column where we have a reading. And when do we have a reading? We only have a reading when the red probe is at pin number 2 and black can be either on 1 or 3. Remember, the red probe signifies our anode and the black probe signifies our cathode. So with that in mind, it means that pin number 2, it is a p-type material. It is a p-type material, and it is the only p-type material used to make this transistor BC547. So means that P number 2 is p-type. Then if it's p-type, when 2 is positive, we only get a reading when it's black. It's either on 1 or 3. So it means that between 2 and 1 there is a diode in that direction, and between 2 and 3 there is another diode in that direction. So P, which is our number 2, this is p-type, and 1 and 3, these are N and N. So this BC547 is an Npn transistor. It is an Npn transistor. Then, since P is the only terminal which is unique or which is made of p-type semiconductor and the other two are made of n-type semiconductor, P we can say is our base. P is going to be our base. Now, still from this particular table, how do you identify the emitter and how do you identify the collector? We have already identified the base. Now we want to identify between pin number 1 and pin number 3, which is the collector and which is the base. So this table is going to help us to understand which is the collector and which is the emitter. So at the readings column, one of the readings is slightly higher than the other one. The one which is higher, this is going to be my emitter, and this is going to be my collector. So that means pin number 1 is going to be my collector, and pin number 3, it's going to be my emitter. It's going to be my emitter, and we have successfully identified the collector, the base, and emitter of our transistor, which was what? BC547. Now, since we have identified the collector, we can be able to measure the transistor current amplification gain, or HFE, and that we are going to select on our multimeter HFE, and we already know that this particular transistor is NPN. So where we have HFE, we have PNP and NPN. So with my transistor facing me, I know that my first pin is the collector, my second pin is the base, and my third pin is my emitter. So where I have NPN, I'm going to fix my transistor. I'm going to fix my transistor and look at the reading 344, and then record here HFE is equals to 344. So this is my transistor gain. This is my transistor gain, HFE. Let us go on to the next transistor. Our next transistor is BC557. BC557. It is still under bipolar junction transistors. So I'm going to fix it on my breadboard like that. Remember, when the flat side is facing you, the farthest pin to your left is pin number 1, the center one number 2, and the far to your right number 3. So let me fix it on my breadboard like that. Here are my probes. I set my digital multimeter to diode test, where we have diode and continuity test. This is my table for BC557. Farthest pin when the transistor's flat side is facing me, farthest pin to the left, 1, 2, 3. So let me start. So we have pin number 1. Pin number 1, we have red on number 1, black on number 2, and you can be able to see we are getting a reading there. That is 727. Then we have 1 on red, 3 on black, no reading. Now number 2 is on red, number 1 black, no reading. Then we have 2 red, 3 black, reading, and 3 on red, 1 on black. So we only have a reading when the red probe is on pin number 3 and the black one on pin number 2, which is to 730. From the readings we have obtained, we can conclude that it's only when black is on 2 we have a reading. So 2, it's only getting a reading when either 1 or 3 are connected to 2, and 2 is on black, which we said is our cathode. So we can say that 2 is an N-type material. 2 is going to be an N-type material because the rest we are not getting current flowing through the diode between those two terminals. Then now between 1 and 3, both of them are going to be p-type material, and 3, because it has a higher value, is going, this is p, and because it has a higher reading, this is going to be my emitter, and 1 is going to be the collector, and 2 is going to be the base. Now let's measure the HFE of this transistor. So this is my multimeter. I set it to HFE. This is my transistor, my flat side facing me. 1, this is a PNP. 1 is the collector. So this is how I fix it. And then the reading is 337. So my transistor HFE is 337. So we can conclude that the first transistor BC547 was an NPN transistor, and BC557 was a PNP transistor.